So welcome everyone. This is the Quant University Spring School session. And today I'm very excited to have Ryan Carrier from the ForHumanity project and Shea Brown from BABL AI. Did I pronounce it right, Shea? BABL? B-A-B-L? BABL,
That's right.
BABL.ai. And we're going to be talking about a very interesting and an exciting topic, which is algorithmic auditing and talking about risk in artificial intelligence. Now, most of the people are kind of excited about the cool things AI and machine learning has brought into our lives. But we're also seeing that the pace at which the technology is growing and the way in which we are adopting these technologies without scrutiny, without kind of looking at a 360-degree perspective of what are the possibilities, good and bad, is becoming something of concern. So in that realm, the whole area of algorithmic auditing is kind of coming as an important way of addressing some of these concerns and also kind of getting the disclosure about what these areas are and how do we make sure that we responsibly adopt AI and machine learning products. So I'm very excited to have this discussion with Ryan and Shea. So I'll make the introductions in a minute. And for people who are joining in from various parts of the world, if you haven't had an opportunity to type in where you're joining in from yet, please do. So we have people from various parts of the world join in, Netherlands, France, et cetera, et cetera. And we are going to be recording these sessions and sharing it with everyone if you are not able to join in. And this session is also being streamed live on LinkedIn and on YouTube. So let me share a couple of slides before we can hand over the stage to Ryan and Shea. So let me just go into full screen mode. So for people who are coming to the Quant University session for the first time, welcome. So we started out doing these sessions, the weekly sessions, since it's last summer. So we've had more than 30 sessions so far. And every week we invite eminent academics, professionals, and experienced thought leaders in various areas to come and present the work they've been doing. And we have had people from various universities, various organizations, and we have had very good response. And we have had people from 13 different countries come down to these sessions. And it's been relatively easy to come down to these sessions because it's just a click of a button. But from a knowledge sharing perspective, I think we're very fortunate to have all these speakers come down and share their immense knowledge with us. So I'm very thankful to you all for making that happen. For people who don't know us, my company is called Quant University. We're based out of Boston, Massachusetts. We started out in 2013, focusing on the intersection of data science, machine learning, and finance. And so we have been doing a lot of educational programs for various companies and organizations. And now many of these programs are available online. And we're also building a Q sandbox, which is for primarily exploration and also for rigorous testing of various machine learning and AI algorithms. So for people who are interested in joining us, there is the summer school happening, which is going to start in June. So please stay tuned for details. We have a couple of different courses for people who are getting new and getting into machine learning and AI. There is a bootcamp on how do you build machine learning models, and also focusing on the financial services industry, how do you build various kinds of machine learning models. It's a 12-week bootcamp. We're doing it in partnership with Premier. And in addition to that, there are a couple of risk-related courses. And again, these are catering primarily towards the financial services organization audience. One on stress scenario testing and evaluation, another course on algorithmic auditing for AI and machine learning models, and the third course on model risk management for machine learning models. So all the details are available at the QR code, and I'll also be sharing the links to the slides where you'll be able to access that information. In addition to that, as most of you know, I'm originally from India, and I still have a lot of family and friends back home. And it's just devastating to see the second wave of COVID, which has hit us back in India. And I keep hearing heart-wrenching stories on people in dire need for various supplies. And we are doing a fundraiser next Friday. It's going to be a masterclass, and it's a donation. We'll accept any donations you can make. even if you're not able to attend this session online, please try and make a donation, and we'll pool all the resources we can and send it over on whatever best we can to help us help people back in India at this time of need. Another quick announcement, we are doing a session next on May the 25th in partnership with the WEF and WAIFSC and NVIDIA. So it's going to be a 1-hour session, and we're going to be doing it immediately after the session, the next week's session we have on May the 25th. So please feel free to register for that. So without further ado, I'm going to introduce our speakers for today. So Ryan and Shea, so we got to know each other through Ryan's initiative, the ForHumanity initiative. He's doing a fantastic job in bringing the community together, like-minded people who are working on various areas in machine learning, AI, and various areas, but also building out a community on how do you bring all these thought processes together and formally make a whole a practice out of it. And he's going to be talking about some of the areas of focus in the context of independent audit of AI systems, and also thinking about like how do you make this more formal rather than kind of having a very piecemeal approach. And then Shea has both an academic and a professional side of a career. So I'm very excited to hear about what you've been working on, Shea. So he has worked at various working groups. He also teaches at the University of Iowa, but also runs a company called BABL AI, which is focused on algorithmic auditing. So I'm very excited to have you both, Ryan and Shea. Welcome. And I will hand over the stage to you and would love to hear your thoughts.
Great, thanks. What are we doing with slides? Do you run them?
So you can share your screen. You can share your screen.
I'm going to share screen. Okay. Yeah. So let me pull that up. And from the beginning.
And Shea, when your turn comes, you can share your screen and walk from there.
Or I can run it for you too, Shea, which would be one possibility, except I shared it too fast and I've got to share screen and then do this. Okay, cool. All right, so ForHumanity is a 501c3 public charity, started in 2016. Wow, this slide's out of date. We have 350 contributors now from 44 countries. And it's a place where everyone can come to join. The mission is very simple. Examine and analyze downside risk associated with AI and autonomous systems, and where we can identify risk mitigations to ensure the optimal outcome, and thus where this name came from, this massive, overly ambitious, silly kind of name called ForHumanity. But we love it. We love the name. We love what we do. We love who we work for. And it's a great reminder every day. We can never be for everyone, but we want to try. And that keeps us focused on who we work for and the reasons that we do the things that we do. Since 2016, I'd written a lot of words on future of work, technological unemployment, rights and freedoms in the fourth industrial revolution, data ownership. Is that a solution to some of these challenges? But the work that we settled on as the primary mission was looking at the challenges of trustworthiness in AI and autonomous systems. And so far, from a regulatory perspective, even with some of the new rules, it's mostly the Wild West. It's mostly ungoverned. There's very little oversight. And thus, there's actually very little trust. And given Quant University's background and the types of people that come, you actually should be able to relate very closely to the thought process that I had from my 25-year finance career, which is in finance, in independent audit of financial reports, we have an extremely robust system of trust based on financial accounting, reporting, and independent audit. It's so trustworthy, I would argue, that there's entire businesses and industries built on the back of these numbers. And it's not the case where, if you're going to build a business or an industry on the back of anything, you're going to go through it and you're going to ensure that it's extremely well done and that the numbers are accurate, the details are in place, and that there's limited conflicts of interest and so on. And that's not actually what happens. The system is so robust, everyone is so comfortable with the transparency, the process, and so on, that most in finance simply deploy these financial reports and accounting. And that level of trust, that degree of trust in the process is what we need to get into our AIs and autonomous systems. And so what we're aiming to do is to replicate financial audit, accounting, third-party standards, rules, and criteria. We're aiming to replicate that for AIs, for autonomous systems, everywhere they impact humans. And the theory here is to borrow from that experience. Or, there's no pretending that this is some ultra creative, nobody else thought of it. No, we want to borrow from what we already know. We want to borrow from the experience. We want to borrow from the lessons learned. Take an example like Enron and WorldCom and Arthur Andersen and the damage that they created into financial accounting and reporting and audit, learning from those mistakes. The government learned in the United States, Sarbanes-Oxley remedied some of these situations, and they took a great system, an amazing system, a system that works 99.99% of the time without a hiccup, without an issue, building a massive infrastructure of trust. And even after those massive debacles, which were frauds, they were collusion, we learned, grew, improved the system. And now we have an even more robust system with a high degree of independence legislated by design. And so we want to borrow from those systems and we want to bring them to the table in terms of replicating that in independent audit of AI systems. Some of you may have heard that practitioners in the industry today saying that they're doing AI audits. We reckon it's actually kind of a bit of a lie is not the right word because they're not doing it intentionally. It's a misnomer or a misuse of the word. So actually, Shea and I produced a piece together called Taxonomy. And this table that's on the slide in front of you references why we know that there's no AI audits being done. What's happening, and it's a very valuable service. I'm not knocking the service. I'm not knocking the work. It's hugely important. But what's happening is an entity that's an expert, like Shea's firm BABL, will engage with a client directly. And that two-party conversation where they're doing audit with a little a, deep dive kind of work, right? Trying to build into responsible approaches, better bias mitigation, privacy by design, and so on. But they work together. And when they work together in that fashion, that's called an assessment or a consulting gig. It is not an audit. And here's why we know that. When we talk about audit with a capital A, it is a very precious term. And remember, it has a 50-year track record. So even though AI is cool, machine learning is cool, it doesn't get to take words that already have a track record, that are already well known, and just change them up, right? So we have to focus on audit and what it really means. Audit means three unique things. Number one, it has to be done by certified practitioners, of which there are none in the world today for AI. Number two, you should have independent third-party sets of rules. Why is that? Well, let's take an example over here where if I'm providing that consulting service to a company, if I show up with my own rules, most likely I'm going to have the systems to solve those rules. And where is the check and balance that manages the conflict of interest of, is that a sufficient set of rules? Is it all of the rules? Or is it more a reflection of the toolkit and the data set of the supplier? So you have to have an independent third-party set of rules. And the third and most important thing is that audit is a very unique contract. It is a three-party contract. You have your auditor, you have your target of evaluation. And unlike this assessment work over here, pre-audit service, which again, hugely valuable. But when we get to the audit time, what happens with an auditor is the work is done not with the company, not with the target of evaluation, it's done over the target of evaluation. And it's done not on behalf of the company, but it's done on behalf of the third party, which is either intended users or more often the public. And this is why when we look at accountants, they are called certified public accountants. It's who they work for. It's who the auditor works for. The reason this is important is it creates a very important tension between the target of evaluation and the auditor. So let's say Shri was my client and I'm the auditor and I'm coming in to do work, right? We've known each other for years. I trust him completely. He's passed many audits before. So I walk in, he says, I got a new system, Ryan. Great. Let's audit it, right? So now I ask, have you built the algorithmic risk committee? And he's like, yeah, Shea and Susie and Sally, they're on the committee with me. And I smile. I know he's telling me the truth, but here's what I have to say as his auditor. I got to lean in and I got to say, Shri, you got to prove it. You got to show me the meeting minutes. You have to show me the roster. You have to show me how the algorithmic risk committee impacted the system. Why? As your auditor, because there's this tension between the two of us, the public is relying upon the auditor to deliver fair descriptions of compliance or non-compliance. So I sit back and I have to know that Shri is compliant. Because what happens is if I say that Shri is compliant and he has not, who is liable for that? Not Shri, me. So the nature of the auditor relationship with the target of evaluation, by rule of law, Sarbanes-Oxley, not every country has this, but our work has it, and Sarbanes-Oxley and other laws support this. It's by rule of independence, as the auditor, I can get no other remunerations from that entity, from my target of evaluation. I can't do pre-audit service, consulting strategy, nothing. So I have no upside potential except my audit fees. But what I have to wear is the downside risk of false assurance of compliance. When you have that system, when this tension exists, this is what builds the infrastructure of trust. Because now the public looks at our reports when we say that Shri's business is compliant, and they go, why would he say otherwise unless it's true? And so you eliminate those motivations, you eliminate those conflicts of interest, and you get a more trustworthy set of governance, accountability, and oversight. When we talk about the space, there's 4 key players: auditor, target of evaluation, pre-audit service provider. This is hugely important because we don't want failed audits. Remember, we serve, ForHumanity serves people. We want compliance with these audits because that's what is best for people. So you want a system that's well-functioning, transparent. Compliance can be achieved if well earned. So of the players, auditor, pre-audit service provider, target of evaluation, what's the one thing that neither of these groups can do, pre-audit service or auditor? They can't make the rules. So we need a third-party body that does that. And that's the role that ForHumanity aims to play in the equation. On behalf of people, curating and forming crowdsourced best practices or compliance with the law in terms of auditable rules. And one of the key things about being an auditable rule is that it must be binary. It must be compliant or non-compliant. Why? If I'm the auditor and I'm looking at something and wondering if it's compliant, what am I going to say? You know, it's a no-brainer. I have to say non-compliant because otherwise I put myself at risk in an undefensible position. So it has to be binary, compliance or non-compliance, when audit rules and criteria are built. That's the background, that's the nature of what we're trying to build in terms of the infrastructure. What we are encompassing with these audit rules is a holistic system looking at ethics, bias, privacy, trust, and cybersecurity. Some of these are less mature, like ethics and bias. Privacy is kind of middle ground. Cybersecurity has been around for 2 decades or so. But we need to look holistically at the system to make sure that all things are in place. There's no point in having privacy by design if it is not a cyber secure situation. So we have to examine holistically each of these AIs and autonomous systems, and we do it in 2 ways. And then I'm going to hand off to Shea. The first is that we start with top-down governance, oversight, and accountability all the way to the board level, making the board culpable for massive or systemic failures to look at, examine, and mitigate risk. Down to the CEO, Chief Data Officer, we build a set of criteria, again, in these 5 categories, trying to identify all of these key risk areas and build criteria around them so that we have top-down governance, oversight, and accountability across every AI, every autonomous system that impacts a human. The other elements of what we build is horizontal. So we look at every AI, every autonomous system in specific to make sure we understand the unique and nuanced ways that it might impact humans or create challenges of bias or ethics or what have you. And so this holistic approach, we want to create these criteria, we want to create these rules. Now, this is the last key thing, and then I'll hand off to Shea. We're not kings. ForHumanity is not kings. We are not legislators. We are not a duly elected body. We are essentially a secretariat using crowdsourced techniques, fully transparent, iterated over and over and over again, trying to get to these best sets of rules. But what we do with those at the end is we submit them to the authorities. We submit them to regulators, governments, governance bodies, any other authority, and we say, here's our translation of the law, of the rules. What do you think? Are you good? Oh, we missed some things? Okay, we'll go redo our work and we'll fix it and we'll come back. Are you good? Yeah, you're good? Fantastic. So now we will sit in the center of that ecosystem, licensing auditors, licensing compliance by design service providers, people building compliance in a box solutions, pre-audit service. Everyone who's qualified gets a license. There's no restriction to it because we want more and more and more compliance. And so that's the role that ForHumanity aims to play. We welcome all to join us. Your voice is valid and necessary and useful in this process. And you can find us on the website at forhumanity.center and check things out. And with that, let me hand off to Shea to tell you how to practically implement this kind of work.
Well, thank you, Ryan.
Yeah, thank
Shea,
you, Ryan.
Are you going to be sharing the slides?
I think
I can
maybe
do it for you if you like.
Okay.
Yeah, that's fine.
Okay.
So we can. So yeah, let's skip this. So we can go to this one here. Here, perfect. This is the one. Okay, so Ryan gave really good background as to what independent audit is, and I just want to, in this talk, I'm going to focus basically on 2 of the things which up until now people have traditionally called algorithm audits, and now Ryan has sort of clarified the difference, and that those are sort of ethical or algorithmic impact assessments, and also bias audits. And so I'm gonna talk a little bit about those. But this slide basically just says that the things that we're talking about here are really just one tool in the toolbox of a larger ecosystem of AI governance. And there are a lot of different ways that AI can be governed to mitigate risk. And so best practices are included in this. Sort of having the correct regulatory structures within organizations. And that's one thing that ForHumanity audits for. Also, number 3, which is a really important one, and probably the reason we're having this conversation in the first place, is public pressure and people advocating for their rights. That's the reason why we even know about bias in AI and that sort of thing. And that's really an important part, to have the public, an informed public, really going out there and pointing out bad actors or cases where bias exists or risk or harms are being propagated. And of course, laws and regulations, that's something which is now coming, and it's been a long time coming, but I think we're finally at the stage where we're seeing at least concrete proposals for laws and governance of AI legally. And then of course, algorithmic audits, which is what we're talking about today. You can go to the next slide. So again, it's one tool in the toolbox. It's not everything, but I think Ryan and I would agree that this is a pretty important tool and one that we think should be in place. The thing that I'm going to talk about now is briefly this idea of an impact assessment, an algorithmic impact assessment. Now, this is a paper that some colleagues of mine and myself at BABL published just a couple months ago, the Algorithmic Audit. And at the time, this was before Ryan and I hashed out the taxonomy, and I actually understood, and I should have called it the Algorithmic Impact Assessment. But in any case, hindsight's 2020. You can go to the next slide. So what I'm going to talk about now is just sort of a general methodology that we use at BABL when we do impact assessments. And this is not by any means the only way to do it. In fact, probably there are a million ways to do impact assessments. This is the way that we sort of converged on that works best for us. And what the main goal of an impact assessment is essentially to figure out where are the potentials for harm to human beings. And so in order to do this, the first step is really gather the full context of the socio-technical system around which the algorithm is being used. And this is really important. And sometimes it's one of the things that's hard for like an individual data scientist, let's say, who's working in the trenches, has a hard time sort of pulling back and looking at this. How is the system being used? Who's using it? Where is it? Who's going to be affected? Who are the stakeholders? And step number 2 is listing those stakeholders. Who are the people who are going to interact with this algorithm? It could be, the developers are one, the people that the algorithm is being used on, the people who are using the algorithm, and society in general, of course, is always a very important stakeholder to consider. And here we take special note to power differentials. And this is important when you're talking about the possibility for harm, because in general, the powerless are more likely to be at risk in any situation, and especially one where you have algorithms working, than the powerful. And so in some sense, you really want to have in front of your mind, who are the people who have the least power in this situation, and how can we best serve them, and how can we sort of best identify potential for risk or harm to them. And as a third step, we have to make an assessment of the various features of this socio-technical system that can impact those stakeholders. And so this is things like bias, that's a feature of a system, the effectiveness of the system, how much transparency exists. And in our paper, we have broken these down into sort of subcategories, because there's, these are very, very broad categories. You can go to the next slide. Yes. So this first process of doing this risk assessment, and then there's a lot more to it, which I won't get into. That's just the beginning 3 stages, but the hard work is really figuring out and identifying where the risks can happen. And in particular, which features of the algorithm, and by this I mean the whole socio-technical system, which of those features, what property of this socio-technical system is the one that's going to lead to the most risk, the most harm that could potentially happen. And once you've done that, oftentimes bias becomes one of the key things that you'd like to look at. And so bias audits is a sort of a term that is coming up a lot. And basically what you're doing is you're testing this sort of narrow algorithmic system, the algorithm, the machine learning model for bias. And there's a really great paper by the Ada Lovelace Institute talking about black box auditing of algorithmic systems. So for the moment now, we're going to assume that the algorithm is just a black box. This is not always true, right? So by black box, mean we only know the inputs and the outputs. There are cases perhaps where we might have access to the code, or we might have more knowledge about the system. And so potentially a gray box where you have some knowledge of what's happening. But given that intellectual property is a thing that people protect, at this moment, I'm just going to describe this as a black box. So a black box is exactly what it sounds like. You have inputs, something happens in this black box, and then there are outputs. And essentially, this is all you have access to. And the only things you can control are what you put into the box, and the things that you need to assess are what happens on in the output. Okay, so this is the only tools that you have. Now, in general, the kind of auditing we're talking about and the kind that BABL and ForHumanity cares about are algorithms that affect people. And so in general, you have data about people that has to get into the algorithm. And so there's a filter, there's some way, people don't just have data hanging around them that just gets dumped into an algorithm. There's some way of extracting that data and gets put into the algorithm. And so that filter is critically important. And if you go to the next slide. So as an auditor, you have to really pay careful attention to what's happening in that filter. And not only that, as you'll see in a minute, in order to test for bias, we have to also categorize or classify the people into groups of some sort. And that's going to introduce bias in and of itself, because the auditor or the person who's doing the assessment of bias is making that classification. And that's, people are biased, and you have to be careful that you're not introducing more bias, or you have to at least be aware of the bias that's being introduced. And the filter itself also will introduce bias. So there are things like non-response bias. If you're using a survey data and people don't fill out all the questions, there's differential access to technology. Let's say the filter is a cell phone, and if you only take data from iPhones as opposed to Androids, that's a filter that's going to change the population of people that the data that's getting fed into the algorithm. And you can go to the next slide. So now let's step back and talk, what's the broad strategy for doing a bias audit? Once you sort of have really thought deeply about the biases and assumptions that you've made, the basic idea is to classify inputs. So you take some testing data, which you've classified according to group. So normally this is protected characteristics, things like race, gender, age. You've classified them in some way. You feed them into this black box, and you look for systematic differences in the output. And those systematic differences typically that you're looking for are ones that are sort of irrelevant for the working of the algorithm. So places where race and age and gender shouldn't matter in the output. In the case of some algorithms, like in the medical field, perhaps those are relevant factors and there should be differences. But in the case of, for instance, hiring or something like that, there should be no difference based on those classes. Now, there are two broad ways that class membership can be encoded in the data. There's explicit class variable and there's proxy class variable. And if you go to the next slide. So explicit class variable is a case where part of the input is literally that class. So for instance, I could have an array of numbers. One is representing the age, could be race, weight, activity level, gets fed into the algorithm, and here I have the probability of being diabetic, just as an example. In this case, age and race are explicit class variables. So you're literally feeding that into the algorithm. Now for a proxy class variable, you could use things like zip code, yearly income, an image of your face, your name. These are things that aren't explicitly carrying that class label, but could be proxies for whatever class that you're looking at. And when I say class now, this could be race, gender, age, socioeconomic status, those sorts of things. And if you go one more, so let's talk a real quick example, face detection. And I don't want to take too long going through this, but here's an example on the left from Twitter. And this is actually neither of these are strictly face detection. These algorithms are a little bit different, but you could use face detection for this. So people notice that Twitter's auto cropping algorithm, essentially, if you were to take two faces, one of which was darker skinned, the other was lighter skinned, So in this case, it's Barack Obama and Mitch McConnell. Twitter's algorithm would auto crop most of the time on the lighter skinned face. And this is an example of bias, where there's no real reason why it should choose to crop over one particular color skin face than the other. And so this is another case of bias. Now on the right, this is a case with Zoom, which is what we're using right now. This is a researcher who realized that his advisor, who was of African descent, his face was not getting, it was getting recognized as part of the background. And this was, and it was happening sort of systematically. And he pointed this out. And the irony is when he put it on Twitter, he ran into the same cropping problem that we see on the left. So his face was the one that got auto cropped on. You can go to the next slide. So in this case, if I were to test for a bias in a particular algorithm for face detection, I would essentially have to follow the same procedure of an algorithmic impact assessment, because what I really need to do is figure out what are the important parts of the algorithm that are really important and could affect people in negative ways. So bias in this detection is the feature that we're looking at. Potential harms could be excess labor. If you have to go and fix that every time you put something on Twitter, that could be a problem. Feelings of frustration, exclusion, that sort of thing. Trauma, people can be traumatized by this sort of not being recognized. The interests and rights could be non-discrimination. You have a right to an education. Zoom is used in educational settings all the time. And so the basic strategy here is to quantify the bias and determine the sources of bias. You can go to the next slide. So here's a quick sort of, I'm going to give you the most naive example. Someone handed me this algorithm and I didn't know how to do this. What I might do is I might gather some images, and this is a face detector, right? And so it's going to put boxes around people's faces. And so what I would do is I would break up the data into groups. And so somehow I've got 3 images here of white women. Okay, so this is an intersectional group that I'm looking at, and I run this algorithm over these 3, and I see it's successfully detected all 3 of these faces. And then what I would do is I would try to do the exact same thing with a different intersectional group. And so I have a picture, 3 pictures of Black women. And if you go back for a second, Ryan, to the last one, what you'll see is you'll notice that I tried to mimic the same position, the same angle as best I could. On the left, there's someone who's looking at a cell phone. There's someone, a slightly older woman who's looking directly at the camera. There's a younger woman who's looking to the left. And if you go to the next, you can see that I tried to mimic that. And imagine what I find is that the central image, the face is not detected. And what I'm so then I have to ask myself, is there bias in this algorithm? It failed, 1/3 of the time on this group, and it didn't fail at all on the other group. Well, the answer is maybe, but we don't know. So if you go to the next slide, the difficulty and most of the time that's spent when doing these bias audits is trying to essentially beat down that statistical, small number statistics. And essentially what you have to do is you have to use as much data as possible, use as many images, in this case for face detection, as possible, to essentially try to find statistical significance, because you can't make any real statement based on those 6 images that I just showed you. And if you go to the next slide, so the basic idea is that statistics of large numbers can really help reveal trends that are hidden in sort of just isolated examples. Now, this was just sort of a flavor. I think there's no code here, but this is a sort of highly technical endeavor, and there's a lot of data wrangling involved in this sort of work. We have to use Python and SQL and cloud computing, and a lot of the work is just building data sets which are sort of really good, high quality testing data sets which can reveal algorithmic bias. And a big part of what ForHumanity is trying to do is to sort of determine or help determine what are the best standards, best practices for doing this kind of work, so that a company like mine, we don't have to make the rules. You know, we don't have to be the ones that decide this is the right way to do it. We have this whole third party that is helping us and all companies that do audits to actually hone in on the best practices, so that we know that we're doing our jobs correctly and that we have support in this area. So these are the websites if you have you know, any interest or interested in learning more, or you can email me if you want to know more about this. Thank you.
Fascinating discussion, Ryan, Shea. Thank you so much for both the introduction for the ForHumanity project, and also going deep dive and talking about, you know, some of the issues. I was kind of reading Rumnam Chowdhury's blog post on the Twitter issue and the paper and the code they've released associated with that. Haven't had a chance to play around with that, but you know, this is really interesting, right? You know, especially with the number of facets we have in here. You know, you kind of talked about the bias audit side of the puzzle, but if you look at the industry, there is this whole other stream of thought in the context of explainability. You know, you're talking about a black box model and how much of it should be exposed, the details, and how much of it should be disclosed so that it's transparent and you understand it. And where does the line fall? You know, who's going to be making the calls on how much of it should be self-policing, wherein you take a stance that this is what you're going to do, and how much of it should be enforced through regulations and you know, some oversight party?
I'll tackle that one first. Not a huge fan of self-policing. I think there's places when risks are lower that it makes some sense. The risks are too high here. AI, autonomous systems, et cetera, are replacing decisions directly impacting millions and millions, if not more, humans. And currently, we've gotten very little or nothing in terms of regulatory oversight foundations. There's no trust. There's no governance, et cetera. So now we kind of have a spectrum, right? You've got the Wild West, which is where we stand now. You can go all the way to the other end of the spectrum, which would be full antitrust. Break up these companies, make them smaller, make their impacts a lot less. Nobody's a big fan of that, especially those companies that might get broken up. So now we have to fall somewhere in between. The EU has come out and they've launched the first salvo, which is they've designated what high-risk AIs are, and they've declared that they will have to go through a conformity assessment. Now, the details of that are unknown. We aim to offer those kind of services of here's what a conformity assessment can be, and so we'll be in the mix of those discussions. But it's a heavy regulatory oversight that often comes with a lot of transparency. The issue and challenge of excess transparency, to your point, Shri, is that it tends to be innovation stifling. And so we actually think that independent audit of AI systems is the right compromise and the right balance. It is transparency by design. We have a whole bunch of disclosures that are required, and we think that transparency creates a virtuous circle of feedback loops to make these systems better, safer, and so on. At the same time, because it's the auditor facing the target of evaluation, you have the power of NDAs and non-disclosure on intellectual property and trade secrets. So you get this balanced blend of transparency and opacity where it's needed in both cases. So I hope that answers the question, but I think that's where we will settle into, at least from a Western perspective. The last thing I'll say about these EU high-risk regs is they put a very distinct line in the sand vis-a-vis China that said, we're not going to be social scoring. We're not going to have ubiquitous biometric surveillance. We are not going to do what you're doing. And it'll be interesting to see, and I think this is one of the things that the US will do. I think the US will step up and basically say the same sorts of things. And then you'll have this coalition of Western allies, not dissimilar to sort of the socio-political spectrum as well.
Absolutely. And, as some of the things we have been doing, coming from the model risk management world in the financial services, there have been a lot of what you call tenets of some of these questions already asked. And it has always been a struggle, even in the model risk management spectrum, to figure out like what should be like a guideline. When you talk about like SR 11.7 being the guiding document, which most organizations follow, that's the extent to which what we have gotten, right? There hasn't been regulation to basically enforce things. But now that we have AI and transparency issues and black box issues, I very much agree. There is the asymmetry of knowledge, which becomes a huge barrier for trust for anybody trying to adopt systems, right? But how do we make it pragmatic? I mean, there is always going to be this discussion of, how much of it should be legislation driven and how much of it should be, best practices driven. And we have also seen some efforts by companies which are building AI systems and saying, okay, you know what, there are some transparency issues. Let's hire a third-party auditor and get a an evaluation done for this sliver of the piece, which is going to be looked at, because you can't just look at a 360-degree perspective. And that's where a lot of contention is like, is that comprehensive enough, right? Now, the biggest challenge I have is, I mean, like I kind of thread the path of on a technology side. I teach machine learning and data science, and I'm intricately familiar with some of the aspects of how do you build these kinds of things and how much of it could be justified in the terms of building with systems wherein you don't have much data. On the other hand, you have the choice of cherry picking what you want with the goal of building things which is going to meet your end requirement. There's so many unique use cases. How do we make it pragmatic? I mean, do you think a grassroots effort and a kind of a coalition-based approach is going to kind of evolve this consensus, or there has to be something like a certification of some sort, wherein like the ISO has some standards, wherein you would say, hey, for manufacturing, for this kind of a thing, you follow ISO blah, blah, blah standards, right? Or if it's like safety for engineering, then follow these standards. And it becomes like industry specific, domain specific, use case specific. And you have all these working groups kind of honing these, towards specific demographics and specific areas, and then kind of tackling the problem in a one-on-one basis. What do you think should be like the best approach?
Go ahead, Shea.
So, I mean, I think that it's going to have to be all of that. So at the moment, I mean, the way that ForHumanity is approaching it is, which I like, is sort of coming in and taking a first pass at what are the areas which we can get disclosure that makes sense, that is not going to be so context dependent that it doesn't have a uniformity. And so requiring sort of internal controls within an organization is a really good first step. But clearly what's going to happen is that as AI matures and production level AI and best practices develop, there are going to be things like ISO type standards for individual AI systems. There'll be individual regulations. There'll be certain industries which are regulated more heavily. So financial industry is already heavily regulated. HR or employment is going to be regulated. It's regulated by the EEOC currently. The FTC is looking at regulating claims of unbiased AI and really trying to verify that that's correct. And so I think that it's all going to happen. And an organization like ForHumanity, let's say, could easily adapt to that by saying, oh, there's this new best practice, some new standard which is out there. We can now decide that that is something that is required in the audit because it mitigates the risk. And then there's disclosure of that particular, some standard form of disclosure for that sort of standard. But I think it has to grow. We have to start somewhere. But there is going to be really industry specific things, because as you know, as a machine learning practitioner, we're going to start uncovering more risk as we get more innovative and new tools. There's going to be things that we didn't anticipate. just look what happens in the social media space with the way advertising and content moderation is done, or at least content serving. Those are things we couldn't have predicted, the filter bubbles and sort of strange dark patterns that are arising. And so, or sometimes intentionally. And so these are things that are going to evolve with time.
Absolutely, absolutely. So for people in the audience, if you have any questions, please use the Q&A window. I'm going to see if there are a couple of questions which we could make time for. So there's one question, I think it's a very specific question. By statistical evidence, do you think something like A/B testing would be helpful for identifying bias? It's probably a question regarding the bias audits you talked about, Shea.
Yeah, I mean, in some sense, the thing, you know, the cartoon test that I just showed is a type of A/B testing, in the sense that you have, you're giving this algorithm one set of data, and then you're seeing how it responds, and then you're giving it another set of data. And you have to do this enough times that you get some statistical significance, because there's going to be a lot of uncertainty. And so anybody who is familiar with you know, how you do this sort of sampling theory and testing for statistical significance, you have to basically look for, there's going to be a lot of noise, you keep adding data, and eventually you're going to settle down that noise. And then, you know, if you see differences in outputs that are significant, 1 or 2 sigma, let's say, or greater, then you start realizing that, well, there might be some meaningful difference in the output. And so, yeah, exactly. A/B testing is a way of implementing that type of thing, and it's very similar to that.
Ryan, I had a question, and I was talking to a startup which was building out some algorithms, and they were a little bit struggling to, like, you know, sell it into a larger industry, right? Because, you know, you always have the asymmetry of power. You know, you don't have like the whole team coming in. So here's sales engineering, here's customer success, here's, you know, support 24/7, and we can kind of, you know, support you with all these needs. And the startup is like, we're hustling, we're innovating, we're spending, you know, and innovating in the laboratory setting and building all these. Now, do you think, you know, if there are like a lot of checks and balances in terms of algorithmic auditing and regulations, it's going to stifle innovation, wherein smaller companies will find it difficult to compete with larger companies who would say, you know what, we have a larger company, we have a large department which does risk management, and they'll take care of all these aspects. So are we going to create a system wherein it's going to be, no pun intended, biased towards larger entities who are able to put in the time and effort to, like, you know, build on these, you know, systems, to compare to the smaller entities who are, you know, going to struggle to get, I mean, even selling into the defense is such a big hurdle for smaller companies, certifications and kind of getting all the clearances and all the stuff. So what do you think? How do we make it as an even playing field so that smaller entities can also kind of compete at the same level?
The answer is yes and no. And, you know, I just want to be clear on that. Now, the real answer to that, we created a GDPR certification scheme for the UK government. And we're going through thinking about this issue of kind of big company versus small company, but it's the law. We took the law and codified it into a set of audit rules. And so what we were staring at was, okay, well, if you're a 2-person shop and you're trying to be GDPR compliant, where could we, you know, make this easier? And the answer is you can't. It's the law. So instead, we are trying to take a different approach. We're not there yet, but I think this is the right approach, which is you want to create societal leverage that supports small and medium enterprises by providing public goods that allow for robust compliance with best practices. So if you ask me the question full stop, is what we're building stifling of innovation? I'm going to tell you no, because what the foundation of what these rules and criteria build is just trustworthiness. It's built-in governance, oversight, and accountability that's valuable to humans, which in the long run is profitable. So now what we have to do is we have to take a system that is difficult to comply with, right? If I walked into Google today, said, here's the rules, they're going to stare at me cross-eyed because they know it's going to hurt to be compliant, right? So in the beginning, compliance, especially with existing systems, because you got to backfill a whole bunch of stuff that you didn't prepare for from the outset, that's tough, that's hard, it's going to cost something, and nobody's going to be a huge fan. But there's a place that you get to once you start to follow the rules from the design phase all the way through to decommissioning, where you build compliance by design. And what I will tell you, and I'm very comfortable saying this, is that once designers and developers get comfortable with building this into the process, they will find it better.
Mm-hmm.
It is more robust. It's more transparent. It's got better documentation. And then to sort of tackle Michaela's kind of question, what it allows us to do is it actually allows us to examine bias in its many forms, just as one specific example. Because what we're doing is we're taking out of the hands of the designers and developers who have massive confirmation bias, massive sunk cost bias, and we're building in risk mechanisms that allow them to avoid making huge mistakes. Instances of ethical choice all throughout this process are made because designers and developers are taught to solve problems, not recognize when they've made an ethical choice that might have a longer impact. So when we examine bias as a whole, and when I say a whole, I mean a really big whole. When we look at the 300 forms of cognitive bias, when we look at all the elements of non-response bias, when we tackle bias in our data, labeling, data sets, benchmarking, representativeness, architectural inputs, outputs for disparate impact, and then if we see bias through that process, do it all again, right? It is a more robust process that will build more trust in the long run, will be more useful, more profitable, but that doesn't mean it doesn't come with costs and expense at the outset.
Absolutely, absolutely. And I think this is something, we have also emphasized many times, and many times it's the question of how do we set the discipline, right? Because many times you can cut corners just because you want to build something and deploy faster, and we'll figure out we'll look at the beta, let's get the beta out, and based on feedback we'll iterate upon it, kind of a thing, right? And I think there is definitely, especially now that the regulators are kind of getting involved in the RFI, the 5 entities which are going to put out the RFI for financial services specifically. And then in the Europe, the discussion about categorization of different algorithms, looking at the criticality of algorithms. In addition to that, looking at this whole notion of what aspects of it should be disclosures and what aspects of should be kind of bringing in that perspective that you are not only looking at the algorithms as ways of making things cheaper, faster, kind of a thing, but also using it in a responsive way. I think there is definitely something we all have to do a better job in educating ourselves and keeping in touch with what's actually happening, but also getting involved, because various industries have their own stories and processes. And if you don't get engaged, it's going to be hard to kind of contextualize what are the areas of concern. And the whole discussion of data and bias is just coming into the limelight in the last few years. Now that once the systems are operational, we are realizing that there are biases and we are quantifying it, we're discussing these, right? So I think definitely we should have more discussions on this. I know it's 1 o'clock and we had a fantastic spirited discussion. I'm very much thankful to you both to spend your time, sharing your thoughts. And please check out the ForHumanity website. And Ryan is so gracious to invite everybody into the community and also shares quite a bit to the community with respect to documents and everything. So I encourage you to continue the discussion online and keep in touch with what's actually happening. And feel free to share any questions if we haven't had a chance to answer in this session. And we will make the slides available, what Ryan and Shea shared with us today. And let's continue the discussion online. Thank you again, Ryan. Thank you again,
Thanks,
Shea.
Sri.
Thank you.
Yep.
See you.
Thanks, Shea.
Bye-bye.
Cheers.
Thanks.